So just to remind you, the time of concentration was the time at which all parts of the watershed begin contributing to the runoff from the basin. It's like from each part of this watershed, they will contribute to the flow at this outlet. And we also discussed this time of concentration. It's about time, like it's not about the maximum distance the water is traveling. Rather than that, this is the time the maximum time required for water to come into this outlet. So we also knew the time of concentration is the summation of travel time for sheet flow, shallow concentrated flow, and open channel flow. In your previous class, you may find that here I wrote pipe flow plus open channel flow. That's because the storm sewer, it can be a circular pipe, but the flow inside the pipe is still open channel flow. So at this slide, I just directly wrote down the open channel flow because whenever we have open channel flow, we have to calculate in that way. There is no exact pipe flow in this time of concentration. So today we will do the class example 20, which you can download from Canvas. I uploaded an empty class example 20 there, and you can work on that. So let's read the question. Calculate the time of concentration for point C here for the given urbanized watershed of the Rhode Island, that in is just extra, which is shown below. Total length of the watershed is 13 feet. You can see that. After 1,000 feet, there is a trapezoidal channel of 300 feet length with 1:1 slope, bottom width 6 feet, and depth of water 3 feet. It's like after 1,000 feet, this is the trapezoidal channel. The channel surface is paved with asphalt also. So basically the surface type at this watershed and this trapezoidal channel is same. Both are paved with asphalt. And they also mentioned flow type is open channel flow for this last 300 feet. Okay. And given that 2 years, 24 hours rainfall is 3.5 inch. So this is the top view. You can see that this is the watershed and this is the channel. And the length is given. Since for watershed, the wet slope is 2%. So from side view, it will look like this one. And for the open channel in trapezoidal section, the bed slope is 0.4%, so obviously which is way less than 2%. So it will look like that. So we will start to solve this question as usual from given values. So all the given values are here. And this is the cross-sectional view of the trapezoidal section. The bottom width 6 feet. The depth of water is 3 feet. And the side slope is 1:1. And this is the previous picture. You already know about that. So what we will do, we will calculate the time for sheet flow, shallow concentrated flow, and open channel flow separately. And then we will just add all of those 3 times together to get the time of concentration flow, time of concentration. So all the equation for sheet flow, shallow concentrated flow, and open channel flow, you can get that from lecture 28. But again, I typed all the equation here as well. So that was the equation. Now we have to find N, L1, P2, S0. Let's see which values are given already. So P2, that was actually 2 years, 24 hours rainfall in inch. So that was given 3.5 inch. The S0 was bed slope, which was 2%. So that is given as well. The L1. So we know that sheet flow can occur for a maximum length of 300 feet. So if I go to the previous slide, the watershed was 1,000 feet. Out of this 1,000 feet up to 300 feet, we can get the sheet flow. So we will take that as a flow length. If the watershed was less than 300 feet, we will take the whole length as a length for the sheet flow. There will maybe no shallow concentrated flow. And now the last thing, N, Manning's N. So we already know the surface type, which is the paved with asphalt. So we have two resources to find out the N values, either 16.7 or 14.4. So let's look at that. Here, if we want to use 16.7, that is the like asphalt bare soil, and the range of Manning's N is 0.01 to 0.016. Now, you already noticed that for table 16.7, we don't have too much options here. So sometimes we may have to use the 14.4. And if you find the value in 14.4, table 14.4, you can use that directly. So there is no problem which table you will use. You can use any of these two. So from here, the asphalt is 0.013. So since there is a range here and there is a specific value, so let's use the specific value 0.013 here. Now, if we have something which we can't find in table 14.4 and we have to use the table 16.7, and all of the value has range, so what we can do, we can take the average of that range, like 0.01 to 0.016, we can take the average of that one. Or based on the case, sometimes we can use the maximum or minimum value, but it's always, if it's not mentioned, so it's always good to use the average value. Okay, so now we have everything here. We have N value, we have LP2S, S not everything, and we got the sheet flow time. The travel time for sheet flow is 3.19 minutes. Okay. So I just added 3.19 minutes here. Now we have to calculate the shallow concentrated flow, next one. And that was the equation. Now, if you look at the picture again, in total the length was 1,000 feet. And they mentioned after 1,000 feet, the flow was open channel flow. So basically first 300 feet, it was shallow concentrated flow. And the rest of that 700 feet, I'm sorry, the first 300 feet, that is actually the sheet flow. And the rest 700 feet, that is actually the shallow concentrated flow length. So that's why L2 is 700 feet. And for V2, we need to know the flow velocity from figure 16.7. So let's see that one. So here, that is the figure 16.7. We know the slope, which is 2%. We know the surface type, which is the paved area. So you will just take the value like this way. And here, based on how you draw that line, it will be like 2.75 to 2.8. I'm taking 2.8. So that is the 700 over 2.8 and 1 over 60, just to convert the total time into minutes. Okay, so we have 4.17 minutes for shallow concentrated flow. So now we have sheet flow, shallow concentrated flow. The last thing we need to know, the travel time for open channel flow. So we need to know the length and the velocity. Length was already given, which is the 300 feet, the last 300 feet. And V3, since it's open channel flow, we have to use the Manning's equation. So for Manning's equation for FPS system, that was the equation. And since the flow, like surface type was same, we can use the same N, 0.013. Since it's a trapezoidal section, you can calculate area, perimeter, and once you know area and perimeter, you can actually calculate the hydraulic radius. And once we have everything, if we use every value on V3, we will get 8.65 feet per second. So that's what we are using here, 300, 8.65, and the time is 0.57 minutes. So now we have time for sheet flow, shallow concentrated flow, and open channel flow. And if we add these three together, in total time of concentration is 7.93 minutes, which simply means water from the farthest point will take 7.93 minutes to come into the outlet at C. So that is the end of class example.